Okay, welcome to Fleet Live Office Hours. Let me double check something. All right, glad to be here. Let's have a good time. So thanks for tuning in. I'm hosting these myself, largely myself. There's no large organization behind it. Purpose of these is to answer technical questions about Fleet, deployment, configuration, the code base, anything you're curious about. I might not have all the answers, but I'll try to reason through things and point you in the right directions. Also, kind of purpose of this call is to have another avenue for contributors, customers, open source users to have another way to interact with Fleet. So if things are quiet in chat, I'll work on some bugs or some stuff I'm working on. That's the plan. So I think today I want to talk about hardware-backed authentication as like a topic. And part of the reason is because I'm actually giving a talk at NDC Security in 2 weeks about hardware-backed auth, and we are doing some things in Fleet that are hardware-backed, and we're going to be doing more, right? We're going to be supporting Acme certificates, enrollment using Acme certificates with Apple MDM, right? That is that should be hardware-backed for macOS in their secure enclave. So I guess I just wanted to kind of, do like a small part of my presentation, just talk about what hardware-backed is and maybe talk about TPM and secure enclave. Let's see how far we get. So let me switch to my other screen. Yeah, this is fine. Let's remove that. Okay, here's Fleet. Let's do this. Full screen. No, I think this is good. Yeah. Okay. All right. So I'm not gonna go through an intro. Yeah, I'm talking about servers have HTTPS certificates, all of that, but clients, right, devices that we're managing at Fleet, oftentimes they're not as secure in the sense that server doesn't really know if it's talking to a real device. Okay, so when most people hear hardware-backed, they picture something like this. A private key exists, it's generated securely, it's stored somewhere safe. Maybe encrypted on disk, maybe loaded carefully into memory. And that sounds good. That sounds secure, but that's not the property we're actually interested in. The real shift with hardware-backed identity isn't where the key is stored, it's what the system allows you to do with that key. So here's the defining property. With hardware-backed keys, you can use the key, but you cannot read it. Not should not, but cannot. Right? There's no API to export it. There's no syscall to dump it. There's no clever trick or workaround to print it out. The key material literally never leaves the hardware boundary. And that single constraint changes everything when we're talking about client authentication that's hardware-backed. Right, so in software system, identity is copyable, right, because keys are copyable. But in hardware-backed systems, identity becomes non-replicable because the key never exists as exportable data, right? That's the shift when going from software to hardware-backed. All right, so if we're building an agent, right, that means when someone copies the disk, right, where our agent code lives, the disk or the container image or the binary, they cannot copy the private key. The backend will only accept signatures from the original device. And as a reminder, we do have the feature that we have that is hardware backed is TPM-backed HTTP message signatures. So for your OS Core agent, and the current use case is for Linux systems. So I think we only support it for Linux systems. We haven't tried it on Windows yet because our customer that needed this was for Linux. So for Linux, if you deploy an agent, you can use the TPM on Linux to have a private key, and then every request from that Orbit agent, from our Fleet agent to our Fleet server, is going to be signed, and that signature is going to be created in the hardware. So kind of back to the presentation. So instead of treating the key as data, hardware treats it as a capability. You don't get the key, you get an operation, right? You can ask, sign this payload, decrypt this blob, respond to this challenge, right? And that's what we're doing. Here's the slide. That's what we're doing with our TPM-backed HTTP message signatures. We're signing each HTTP request, and that signing operation actually happens on the agent in that Linux TPM hardware. Right, the hardware performs the operation and returns the result, but the key itself never crosses the boundary. Let's talk about some important vocabulary. So first, root of trust. A root of trust is the thing that the entire system ultimately relies on. It's the part you assume is correct when everything else might be compromised. So in hardware-backed identity, the root of trust is the hardware itself, not the operating system, not the container runtime, not the workload, it's the silicon. Second, non-exportable key. This doesn't just mean we promise not to export it, it means the hardware will not serialize it, the hardware will not reveal it, the hardware will only apply it internally. If the attacker steals your disk, they don't get the key. If they dump your memory, they don't get the key. If they copy the container image, they don't get the key. They can copy everything except that key, the thing that matters. Third, sealed and unsealed, right? Hardware doesn't just hold keys, it controls when they're usable. A key can be sealed, meaning it exists, but it cannot be used until some specific policy conditions are satisfied. And I'm not sure I'm going to get into those policy conditions, but that's where kind of attestation comes in. So usage is gated by hardware, not by application logic. All right, so the next term is measurement, right? And now we're getting really into the kind of levels of security, higher levels of security here. So measurement is how hardware answers the question, what is the system actually running right now? It takes cryptographic hashes of firmware, bootloaders, kernels, and sometimes even configuration. So those measurements become part of the hardware's internal state, and keys can be bound to those measurements, right? So the hardware can say, I will only use this key if the system looks like this. If the system changes, then the key is sealed, it cannot be used. Right, so we are going to touch on attestation here. So once identity becomes non-replicable and bound to measured state, the next question becomes, how does the remote system, right? How does our Fleet server verify that, right? That's attestation. But only briefly mention attestation here, right? So kind of backing up, hardware-backed identity isn't about stronger cryptography. It's about introducing a property called non-replicability. Attestation is what makes that property externally verifiable, right? And for our agent, this is how the application backend, make a note here, learns that the key was generated inside real hardware and is bound to a measured boot state, and not simply that a signature verified. Now I do have to mention that attestation is optional, right? In order to have attestation, you need to have at least a certificate, well, that's kind of basic attestation, a certificate of the manufacturer. So you can verify the attestation signature against that certificate, and against that public key of that certificate. So when you hear hardware-backed authentication, don't think where the key is stored, think who can use the key, under what conditions, and can that capability be copied, right? Because with hardware-backed, possession isn't just logical anymore, it's physical. And that's kind of a turning point when we're trying to increase our security. Let's see where we are. We got 10 minutes in. I have lots of content I can talk about here. But in the next section, I kind of go into the details of TPM. And TPM standard itself is over 1,000 pages long. Let me just skim through this and see if I want to mention anything interesting that's kind of relevant to Fleet. All right, TPM is a secure crypto processor, but there's several versions. It can be even firmware as well. It's got seeds. There are different types of seeds. Endorsement key, attestation key, right? That's kind of the bootstrapping trust. When you get a fresh device, right, you should have a certificate, right, that you can verify against. But it is possible that these endorsement key can change. And of course, if it changes, then you effectively need to re-enroll your device. Basically, I guess I kind of covered it here. So we got the endorsement key. You got your attestation key that signs your measurements. And then endorsement key signs the attestation key. Let me look at my notes. We're kind of getting into details here. That's just for my interest. But the actual hardware identity is under the owner hierarchy. Back here, I listed the hierarchy. So endorsement seed is kind of bootstrapping that trust. And once you bootstrap that trust, once you enroll the device, then you use kind of the owner hierarchy. You generate your actual hardware identity key under the owner hierarchy. Let's see, this is kind of high-level idea of how these work. The hierarchy model, you've got your seed, you've got the parent keys that used to wrap the child keys. Child's keys are stored as blobs, and they're only usable when loaded under the correct parent, right? This is how TPMs scale. This is how you can have a lot of keys in your TPM. Because TPM chips themselves have limited non-volatile storage, so you can't persist every key in that storage. Instead, what you persist are these wrapped key blobs externally on disk. And then the TPM unwraps them only under the right parent and policy. Also, a cool thing about the parent is it is reproducible. Parent keys are reproducible, right? With the same template, the same authorization, the TPM will deterministically derive the same parent key again. So you don't need to store the exact parent key, but you do need to remember your template. Platform configuration registers, right? This is about attestation and measurements. I'm going to skip through this. We're talking about policy. All right, policy comes into the attestation. A lot of detail here, maybe a little too much. And then after initial attestation, you do want to occasionally verify, right? You want to effectively redo the attestation. Apple. Apple's got secure enclave. They solve similar problem, right? They both isolate keys from the operating system and enforce policy in hardware. So Apple built a dedicated security processor into their silicon SoCs, right, to act as a separate trust domain. So when we say secure enclave, we mean a secure coprocessor that runs in its own microkernel, has its own memory and random number generator, and operates under the assumption that the main OS could eventually be compromised. So architecturally, that's not entirely different from TPMs. Kind of the difference is kind of in the integration details and control surface. A TPM exposes a standard command interface defined by that 1,000-line specification, 1,000-page specification. The secure enclave is, of course, deeply integrated into Apple's silicon and operating systems. You don't send raw security commands to it in the same way. Instead, you interact through Apple's system APIs. And the OS mediates access while the enclave enforces key isolation internally. So the enclave is still a distinct trust domain. The OS itself cannot read its internal memory. It cannot extract its keys. It cannot bypass its policy engine. So the operating system is a client of the enclave, not its owner. So from an identity perspective, the most important property is the same as with TPMs. The keys are non-exportable by design. And Apple exposes all this through its API, specifically keychain services. And there you use secure enclave-specific key attributes. So from the app's point of view, you declare key properties, generate in secure enclave, mark as non-exportable. You can also optionally require user presence, and typically you restrict the key to the app. OS brokers that request, the enclave performs the actual cryptographic work, and the policy enforcement happens below the OS boundary, right? It happens in hardware. So when you later request a signature, the OS forwards that request onto the enclave. The enclave shakes policy and returns only the result, right? If the app lacks entitlement, if the device state violates constraints, or if usage rules aren't satisfied, the enclave denies the operation. No fallback path, no alternate API. The hardware can definitely lock you out. So just like with TPMs, this kind of changes the attack surface we're talking about against bad guys. Even if attacker compromises the application process or the kernel, they still cannot extract the private key. At most, they can attempt to invoke a legitimate signing operation while the compromised code is running. They cannot copy the identity to another device. They cannot mint replicas like they can with software-based tokens. So that identity remains bound to that specific hardware. So here's the key difference with Apple's identity model. The keys are typically per app, right? While with TPM, they're kind of globally shared per device. So each app can hold its keys, but there's nothing really preventing another app from trying to use the same keys if it knows where that secure blob is held and what the template is of the parent key. So in Apple world, when an app generates a secure enclave key, it is cryptographically scoped to that application's identity and the device, right? Another app cannot reuse it, even if it's running on the same user account, and that isolation is enforced by OS entitlements and hardware policy. So So if one app is compromised, its identity does not automatically spill into other apps. That secure enclave enforces that segmentation. Identity becomes granular rather than monolithic. So basically at a high level, Apple's, let's talk about attestation, right? Apple also provides attestation for secure enclave keys. It's a little bit easier because there's only a single manufacturer, right? When a key is created, the system can produce a signed statement asserting that the key was generated in genuine Apple hardware inside a secure enclave with specific attributes. And that signature chains back, right, to the Apple control roots embedded at manufacturing time. With TPM, this is a little bit harder because you have multiple manufacturers. It's also possible to swap motherboards, right? So the system with TPMs is a little more complex than with Apple hardware. Attestation is great on Apple. Verifiable claims. Let's see what I want to say about this. Yeah, it's good. And with Acme, we can integrate that directly into certificate workflows and device management. Let me see. I'm talking about per app client identity. I think I already covered this before. I think this is a duplicate. Yeah. Let me think. I think that's it. Architecture diagram of their secure enclave. Yeah. I also have some material on Android. Android's got their APIs. Android's also a bit more complex because different types of hardware. So it's maybe roughly as complex as TPM. And you might want to ask, why is Android different? Well, ultimately TPM was made for servers, right? Not for mobile devices. So Apple runs on mobile, so it needed low power. So they made their own secure hardware approach. All right, we're 24 minutes in. I think that's good. Let's switch to some kind of hands-on work. Yes, I do have a today's plan up here, so let me modify it. So we talked about hardware-backed auth. Next, I wanted to talk about OSV. So this is something I just started looking into. I'm not an expert on this yet. But historically, I think we added vulnerability for Linux back a bunch of years ago, like 2022, looking at the code. So we've had it for a while, for 4 years. So we've been trying to, figure out, vulnerabilities on Linux. But we're using an older feed, and that feed has problems. Let me pull up the actual issue I'm talking about. If I can find it. Here we go, new tab. Okay, so we have, this is the issue. So we're using oval feeds right now. The Ubuntu, for Ubuntu specifically, why can't I highlight this? Strange. Okay, whatever. For Ubuntu specifically, we're using their USN oval feed, and it tends to group CVEs into one definition. So if I go to this link, Something broken, new tab. Okay, so lost internet access. Okay, so this feed, Emacs vulnerabilities, it actually groups multiple CVEs. So this doesn't quite fit with our UI, because if I go to our UI, I go to software vulnerabilities, we kind of split vulnerabilities out separately. I think let's go to software. Emacs, did I put Emacs in here? Let me see Emacs. We kind of have a software. Let me switch to show versions. Let's do this one. Okay, so we have software. That software has a specific version. So we have software specific version, and we have a vulnerability for that specific version of software. But this feed, it kind of groups a bunch of CVEs, bundles them, and it just tells you, like, if you want to fix all of these, you need to update to this version of Emacs. But it's possible you're in a version of Emacs that isn't vulnerable to all of these. Maybe it's only vulnerable to these three. It's just an example, right? But we as Fleet are still reporting and saying your software is vulnerable to all these other ones. Do I have Linux stuff here? Package homebrew. I guess what I want is a type of Debian, or just clicking around, sorry. Here we go, RPM, right? Yeah, so this one, right? I'm saying 11 vulnerabilities. That's a lot. Pretty sure this is not vulnerable to 11 vulnerabilities. We're also kind of bundling. We're reporting too many vulnerabilities, so some of them are false positives. Not the end of the world, but it's kind of annoying. So moving to OSV is going to be per CVE. And I'm just starting to look into this. I see they got Android using OSV as well. So we probably, I guess that makes sense. Android is based on Linux. It shows you a schema, which is kind of nice. The CVEs themselves are aliases. That's interesting. And then it's getting you ranges, when it was introduced, when it was fixed. That's interesting. 0 references. Yep. So the work is kind of splitting, removing our current oval feed and going with OSV. It feels like a big amount of work. And I was just researching how to do it. So my current plan says OSV data fetcher. I was just looking at, you can fetch all of them, but that doesn't make sense to fetch all of this. We don't want to be fetching all of them every time. This is what we do with oval. Of course, it can be done, but we don't do that with NVD. NVD, we only fetch the latest, so it probably makes sense. Yeah, it makes sense to use the same model. And I was just looking at this is a little small. Let me see if I can make it bigger. File, view appearance. Going the opposite direction. 2125. There's an API. Which is interesting. What we're interested in is how to get partial feeds. There's a modified ID CSV. Where is that? Modified ID CSV. Let's take a look at it. So it looks like Ubuntu, and I just want to say modified ID.csv. Modified. I'm just guessing here. Hey, download something. Okay, so what's the usage here? We fetch this file. Do we stream it? How big is it? It's not. It's timestamps for everything that was modified. So what's the flow here? We fetch the first feed. And they're not just, it's Ubuntu-CSV, it's not even, and you've got USNs in here, like, what's the flow? See what my AI agent recommends. So incremental updates be modified. Okay, reverse chronological order. You can stream this file and stop as soon as you reach a timestamp you've already processed. Then fetch only the changed individual JSON file. Understand. So you're saying each one of these has its own JSON file. Where's my... So you're saying this has its own JSON file. So if I do Ubuntu, I do this.json. I see. So I see that this has been modified. I go and fetch the JSON file, which itself can be large. Which one did I fetch? This is just a CVE, just for the CVE. That's a large JSON file. Okay. Sure. Okay, this does not look trivial. So we need to, okay, so we need to just get the files, right? We do this, we have the incremental changes. Just getting the files is a lot of work. Then we need an OSV parser. Is there an OSV parser written in Go already? We parse it. Yeah. Same, we extract same stuff we do from Oval. Then we match against what we have. Yeah, I mean, high level, simple. That's the question I have. Is there an open source OSV parser written in Go? Is there an open source OSV parser written in Golang? Okay. So I think we kind of covered this. I think we just need to talk with engineers, estimate how much work it is. Feels pretty serious. And we probably want to split it. We probably want to do Ubuntu first. Maybe do Ubuntu first. Run in parallel. I mean, I don't think we need to run in parallel continuously. Obviously, we want to run it in parallel during development. But once the results are good, I don't see like a reason to continue running it in parallel, right? So we probably want to split off Red Hat and Debian. Internal package. So this is for Go's vulnerabilities. That's cool. Okay, so there is code. There's packages that already exist. Gives you the struct on Marshall JSON. Okay. Okay, so that there's a library to do that. Well, let me click on it. Published January 29th. That's cool. Okay. Wow, yeah, so it's been released. OSV scanner. Okay. Is this overkill? OSV scanner, probably not. Also seems to be updated. It's got a CLI interface. Okay. So is it a standalone tool? Could it be a dependency? I mean, of course, it can be used as a library. I'm just wondering if it should be used as a library. Hold on. Okay, it is written in Go. That's cool. Can Google's OSV scan? I'm going to move on to something else next. Be used as a library, or is that overkill? All right, let's move on. We got 20 minutes. Let's check chat. Hope everyone's doing good. Let's move on. Yeah, obviously need to kind of finish this so we can estimate it. Looks like it's going to be a lot of work. Another thing I've been looking at is some errors we were seeing in our our own fleet server that we're running. We're using OpenTelemetry there, and I'm just looking at errors it's flagging. Some of the errors are false errors, like if someone's not allowed access to anything, we shouldn't be flagging it as a server error, so just need to recategorize it. But I did encounter an error that did seem real. We got an error where a product was not found. And actually, I don't think I need all this information. Actually, we got enough information for that error. And ultimately, the issue was that we don't have Windows Server 2025. Oh, NVD feed generator. So haven't dealt with this for a while. NVD feed generator, do we have any code here? No, we don't really have code here. This just runs our Fleet server. We check out Fleet and we run these generators. Okay. So we ultimately need to update this to generate these files. Let's see what we have right now in this repo. Fleet server, yep. Okay, so we need to generate Fleet server 2025 file here. So this is actually feature request. Let's file it. I mean, we are late, right? Windows Server 2025. I guess it's not that big of a concern because most of our customers use like client. We're talking, install it on client machines, usually Windows 11. Create story to support Windows Server 2025. I mean, is it a story or bug? I mean, I think it's a bug. Like, yeah, it would have been a story when it first came out. Now it feels like it's a bug. All right, what did this guy said? Overkill for Fleet. Per package. Heavy dependency tree, okay. Okay, doesn't really fit our use case, okay. Okay, so we probably want to go with this official package. That's cool. And this is how file bugs now. I basically have it generate, then I go through the bug and modify it. Let's go ahead and file the bug. Issues, new issue, bug report. What's it called? MSRC, blah, blah, blah. Title. Doesn't matter. think I had an error message. There's a release bug. Actual behavior. Cool. This is irrelevant. I mean, we're getting into specifics here. Okay, I get it. We don't need to, these are the most important ones. It's kind of like the obvious place. And this is another obvious place. Blah, blah, blah. We are late. Like, we've had this bug for a year and a half. I don't know, is this a simple fix? Doesn't seem that hard. Well, yeah. I mean, what if it has no vulnerabilities? Let's just kill this. That's the question. What's the difference between Windows Server 25 and Windows Server 25? Whoops. What is the difference between these products? I mean, obviously. Like, we don't need this section. Release bug, my group, security and compliance. Cool. What if we already have a bug for this? Well, I didn't see it. I would have seen it. We don't have that many bugs. Get the same security patches. Okay. Difference if it only affects the full stop and only reference. This doesn't explain. So in fleet, will we do we assign different vulnerabilities for desktop GUI version versus the no GUI version for Windows Server OSs? It's gonna take a while. Let's move on. So I was just saying, I'm looking at some issues. Let me check. I think I should be able to share. Oh, maybe not. We got 9 minutes. Let's see if there's any comments in the chat. Let's just take a look at what else we have on the docket. Types of bugs to work on. Okay, so this was quick. No, look at product at the matching logic. Fleet matches each host single property ID. Okay, so that's a bug. OS query OS version table doesn't report the installation type. Okay. I mean, Fleet can do better, right? We can query okay. Great bug that Fleet does not distinguish between installation types. Well, I need some clarification. The question is, so are we missing the GUI false or the opposite? GUI false, which will be a false negative, or do we report GUI false for non-GUI installs? False positive. What's the severity of this issue, right? False negatives are more serious. False negatives means we're telling customers they don't have vulnerabilities when they actually do. So, okay, so another bug. Looks like we got plenty of work. And let's take a look at our other bugs. Duplicate. All right, I'm working on this. So what am I looking for? I'm looking for something to pick up. What's my plan? Yeah, I'm looking for something to pick up. Label bug, label customer. My goodness. We may have already fixed this. Right, I think it's pretty straightforward. The problem is if they already have a cert on their device, so like an existing customer, they would need to rotate their cert. I guess that's fine, but it's up to them. Do they want to rotate their cert or not? If they rotate their fleet cert, let me think. I probably need to do a bunch of other stuff. I mean, this issue doesn't seem that serious. So we do have someone put looks like Josh put a customer label on this. I mean, I think I can take this. Windows BitLocker encryption looping. Wasn't it going to work on something else? Fleet enrollment, disk encryption enforcement. Okay. Steps to reproduce that Windows device with a non-standard partition map. I see. Okay. I mean, yeah. I think I'll need to reproduce this first. Makes sense for me to pick this up. But I feel like this is, like the fix is straightforward, but customers want to actually see this update on their existing deployments. That's a problem. But let's go ahead and move this to a board. Security and compliance, drafting, assigned to me already. Ready. Current sprint, milestone, estimate, self-estimate. So I got stuff to work on. All right, we got 2 minutes, last call. It's actually non-deterministic. It could be either, depending which progress IDs go. Wow. Create bug for this non-deterministic GUI, non-GUI issue. It's got it. It's going to do something. All right, we got a comment. Never noticed my FleetDM cert also had that, but I don't think it's broken anything as it's just made. Yes, it is functionally okay. I think it's more about customers asking about it, like, hey, what's going on there? Yeah, it'd be nice to just clean it up. Like, I mean, obviously this could be fixed on the OS side. They could just like hide that and not even show it. Why even show it if there's no data in that field? All right. Well, thanks, guys. I think I'll be out next in 2 weeks. So I'll be at that conference talking about hardware backed authentication. So I think the next I'll do the next live stream 4 weeks from now. Unless I decided to do the 3 weeks, but it's probably going to be 4 weeks. So I'll take a look at my schedule. So thanks, guys, for tuning in, and hope you have a good rest of your day.